Hello, everyone. I'm excited to join you all and learn and teach more about how to use Snowflake to go from raw data to an interactive data application. Or you can also call it the other way around as to how are we going to build an interactive data application from raw data by building an end to end data and ML pipeline, which is what we're going to go do today. Before we get into the workshop, just a little bit about me. I am Vino, and I started as a software engineer and then pivoted into the data space. I worked as a data and ML engineer in different companies, Nike and NetApp and Apple and more. And then currently, I work as a developer advocate at Snowflake, focusing on the data engineering and the machine learning workloads, of course. And you can follow my work primarily on Medium, where I talk about all things data engineering and AI, specifically about LLMs these days, which are kind of hogging the limelight all the time. And follow me on Medium if you want to read more about them and what it means to be a data engineer in the age of LLM and more. Now, for the workshop today, this is broadly what it looks like. The agenda, we will start with, understanding what the prerequisites are, how to install them, and setting up the lab and everything, just ready for us to go use the Snowflake tool. And then I will walk you through a little bit about an overview of what is Snowpark and how do you do this end-to-end ML workflows with Snowpark. So it's nothing fancy. It has 3 different modules to it. You can do data engineering with Snowpark and then ML modeling and also the ML ops stuff with Snowpark. So after learning about all the 3 different components to it, we will straightly, dive into the hands-on lab where we will build an end-to-end ML pipeline. And then in the end, I will leave some time, out for our questions and also talk about what's new in Snowflake, which is all the LLM support and more. With that said, let's get into the prerequisites. And since we're all tuning in online from our own homes, I'm assuming that we would have a good internet connection to download all the prerequisites that we would need. First thing, I want us all to go to quickstarts.snowflake.com, where you will find tons of quick starts about how to get started with different Snowflake features. Today, we're going to be focusing on building an end-to-end ML workflow. So we will go over the intro to ML with Snowpark ML for Python quick start. And then the quick starts at Snowflake are just like step-by-step instructions that will help you go from like absolute scratch all the way to the data product that you want to build. And if you are able to go to quickstarts.snowflake.com, search for machine learning, and you will be able to see the one that's highlighted. And that is the quick start we're going to walk through today. And I'm going to explain every step and every line of code in there to make us all understand how you can use Snowpark to build an end-to-end ML workflow. This is how it looks in the, these are the different steps we have in the quick start. And in the prerequisites, we would expect you to have a Git install and Anaconda or any other package management system. But if you already have Anaconda, that's cool. But if you don't, you can click on the links there. They will take you to the install instructions. So Git and Anaconda, if you don't have it already, please, you can follow the quick start links and install it now. And of course, the latest, not the latest probably, the latest is 3.11, but then as long as you have 3.9 of Python, we are good to go. And before I dive into the presentation, I want us folks to go install the Git, Anaconda, and Python. And suppose you already have them, feel free to tell me in the comments that you already have them installed so I can move forward and we don't have to waste time on getting us the installation steps. I'm just looking out in the chat if we already have it. Do you have Git, Anaconda, and Python versions already installed on your system? Gotcha. I see that some of us are getting Anaconda installed. It'll take a couple of minutes, we will go over our presentation, so that gives us enough time to get all these installations done meanwhile. And of course, we're all data practitioners here, and some of you might already have Python, Git, and Anaconda, and some of you might even have Snowflake installed, so that's all good. And I will also share the link to this quick start. so you can refer to it in case. Awesome. All right, let's dive right into the presentation. When I'm talking about building interactive data application from raw data, what are the steps in between, and what are the challenges in each of these steps as of today, like in the current existing tool stack today? One of the biggest differences between building an ML workflow or a data application versus a simple software application is that a software development life cycle is very linear. You develop locally, test it, deploy it, monitor it, and then it's done. It's just very linear. But when it comes to the ML or any data engineering pipelines, it's just very iterative, because what happens, we have this data engineering team who pulls in the raw data for us and does ETL transformations and curates the data, curates the training data for the ML team. And then the machine learning team or the data science team, it takes that data, works on it, experiments with different features, different model algorithms, and try to arrive at an efficient model for whatever metric they're optimizing for. And what happens if they don't, if some of the experiments are not successful? We go back to the data team and ask for, let's say, updated set of data, and then we try on that with new features, algorithms, and whatnot, and optimization parameters. So this back and forth keeps happening until the data science team arrives at an effective model. But then, even after they arrive at that model, the deployment part of it either goes to an ML ops team, if there is a separate ML ops team sitting in the data, like within the org, or it typically is also done by data engineers, because building a data pipeline and an ML training pipeline are kind of very similar. So what happens? It starts with the data team, goes to the data science team, and then for deployment, it goes back to the engineering team again. And then in the end, it is being consumed by an end team, which is like a business or like, analytics team that consumes it. So the workflow is not at all linear, it's very iterative in nature. And because of this, there is a lot of context that gets lost. If you are a data engineer or a data person, you would have had this experience where someone from the data science team be like, can you pull this data for me? Done. What for? In what context is it being used? Or it, what business case is it solving for that data science team? We don't have a lot of insight into that. And if you're a data science person, you will be like, how hard can it be to just pull the data? It's already there. Why is it taking so many days or so many hours? And you don't have full understanding of the infrastructure and the challenges with the data infrastructure. And because of this loss of context, it becomes extremely difficult to work with these different teams. And the other the other challenge is not just this loss of context, but also that the data is siloed within each. For example, data engineering is working with their own copies of data with local and staging and prod, and then they share the prod data to the data science team. And if there are multiple team people in the data science, they create their own copies for their local development. And then they have their own concept of dev and staged and prod. And in this process, we create multiple copies and silos of data that are sitting across in different, environments, dev and staging and prod. To solve this is why, Snowflake, in fact, Snowpark is helping us. And how does it help us? In each of these phases, like how does Snowpark help you with data engineering, ML, and all the ML ops stuff of it? So let's start with data engineering, and I will explain how Snowpark helps with this data silos primarily. What happened was, before Snowpark came into existence, Snowflake was a simple cloud data warehouse. It used to be. And we only used SQL to do our data engineering tasks, data transformations to write our ETL, transformations and whatnot. And then to do our data science work or to write our Python code, we used external compute. So what happened, as you can see here, is the data team is working with the Snowflake data that is sitting in Snowflake using SQL. But the data science team is creating copies of that data into external compute environments and then working off of that data to build their data science models. And there is a lot of data movement out and back to Snowflake, which is not a great thing to do. If you're working with truly big data environments, moving the data in and out of where it is the least effective optimal thing to do. So what can you do about it is, what if you can bring the ML or the data science component or the Python component into Snowflake. So now you can keep the data where it is, but all the different teams can bring their code and compute to where the data is. So that's what happened after after Snowpark. So Snowpark is a set of libraries. It allows you to write code in Java, Python, and Scala. And so if you have Snowpark in there, what happens is all the external compute is happening within Snowflake. And now there is no data movement in and out of Snowflake at all. So what happens is your data engineering team, data science, all of them are working off of that one single copy of data that is sitting within Snowflake. So there are no data silos. There are no 10 different copies of data sitting around inside Snowflake and outside Snowflake, and it's just a mess. Not there anymore. But if there is just one single copy of data that every team is using, how is it even efficient? Aren't they all going to mess up that single copy? Of course not, because we are familiar with zero copy cloning, where you can create multiple development environments off of the same data by using the zero copy cloning feature, which Snowpark and Snowflake offers. So using that, we're all working off of the same data, but with our own cloned copies. But they're zero copy clones, meaning it's not an entire clone of all of your data set, but just the changes. Okay, so now if we go back to our challenges, the data silos and different teams working with different copies of data was one of the biggest challenges. And we solved that by bringing by bringing the compute and the Python, Java, Scala code to the data instead of moving the data around. And now, all right, so the data silo problem is solved. And the collaboration, how is this context getting lost between one to another? How long is it going to pull the data from? How long is it going to take for the data team to pull the data that data science team is looking for? All of that will be solved as well if everyone in the team is working with just one language. What I mean by that is, if I'm a data science person writing Python code, working with scikit-learn and NLTK and XGBoost and whatnot to build my ML model, I'm dependent on the data engineer to bring me the data, the training data that I need. But if the data engineering team is using Spark, for example, that is going to be a bottleneck for me, because I cannot it's hard for a data science person to go start writing a Spark job to reduce the dependency on the data team. But what if everything is in Python, both data engineering, data science, and even the ops of it all in Python? So it makes this interoperability within the teams super convenient, and there is no loss of context or this external dependency within the data teams. And with all the problems solved, but can we just understand how Snowpark actually works? What is it? And dive a little bit into under the hood of what Snowpark looks like. Like I said before, Snowpark is just a set of libraries and compute. And what do I mean by libraries? Like if you're a Python developer, like pandas and NumPy and scikit-learn, and all of those are external libraries. And Snowpark also has similar libraries that you can use. And it comes with two different API sets. One is the data frame API for the data engineering, and the ML API, ML modeling, and the ML operations API for the machine learning side of it. So since the entire data team is working with Snowpark, it's super easy to work with, if you're working with ML modeling API, it's super easy for you to pick up the data frame API and pull the data yourself, reducing the dependency. And then on the, server side, it also comes with a bunch of compute. And as I said, traditionally, Snowflake only had this SQL compute engine, and it was only able to process the SQL queries. But currently, thanks to Snowpark, it is also now able to process non-SQL code. It could be Python, Java, or Scala, within the same compute engine as well. So it's just that. And another interesting component is with all the LLMs and generative AI coming in, you will now also have access to the container services, which means container services are a way for you to get GPU compute to run all your LLM workloads and more. So it's just the server-side runtimes are just a bunch of compute clusters, but then you could be using standard warehouses as compute clusters or container services as GPU compute clusters based on your workload. But then overall, the summary of this is that with Snowpark, we are able to work, like the data engineering, data science, and the ops team are all able to work off of the single set of APIs, the Snowpark APIs, that will help you do everything end to end by yourself. And how does it work? And when I'm talking about a data frame query, you write a simple data frame and like API, and that gets parsed and translated and formulated into a SQL query plan, which is now run on the SQL engine, which is super easy when you think about a simple data frame operation. It's very functional. But when you go think about, so if I'm using scikit-learn, for example, you cannot run or you cannot convert every scikit-learn function into a SQL query plan. So how is Snowpark going to run them? Snowpark is going to convert the external libraries into a Python bytecode and then run them into a Python, like in a Python sandbox. And that's how it's going to run the non-data frame APIs. And it also has support for, like, the Snowpark ML has support for a bunch of ML libraries, and data frame also has support for external libraries like NumPy, Pandas, and SKN, like scikit-learn and Keras and more. One of the biggest questions that I get asked in this slide specifically is, if I'm already using scikit-learn or Pandas or NumPy, why would I have to use them again within Snowflake? Like, how does it matter, or what is the difference? The biggest differentiating factor here is that if you're using, let's say, Pandas and scikit-learn and NumPy to build your ML workflow, they do not have like native built-in parallelism enabled. And if you're using the same packages but within Snowflake, because of Snowpark's optimization that is being done, all of these packages, all of these functions are run internally within Snowflake in a distributed fashion. So, like, parallelizing the same functions just for optimization purposes is how Snowflake's version of these packages are different from the actual Pandas and NumPy. And now, we already touched upon a bit about the data engineering stuff. So let's quickly dive into the ML, like the modeling APIs and how you can use them. And when we think about machine learning, the offerings vary like drastically on a spectrum. So you could be using a Snowflake Cortex function to just say create summaries of a specific column on your data, and all the way to, let's say, you can even build like a proprietary custom LLM on all of your Snowflake data that is sitting in already. So it, like, the offerings vary like almost on the spectrum. You could use Snowflake's Cortex functions in a second, and all the way to building your own proprietary LLM. But in between is where most of our ML use cases today sit. And we have notebooks and feature store and modeling APIs, and the ML Ops API, which is Snowpark Model Registry. And we also have for the consumption Streamlit, like you can use Streamlit in Snowflake to build any visualization app as a front end for your ML workflows. And in today's like workshop, for example, we're going to be using the ML modeling API and the model registry, and just to show how it works and how you can use them as part of your workflow. And other LLM stuff is probably out of scope of this workshop, but then in the end, I will give you some resources. So if you are interested in building something with Snowflake and LLMs, you will have some resource to get started. And again, in the compute layer, if you look at it, there are like two different types of compute. One standard compute, and the other is the GPU compute powered GPU powered compute instances. And even in the standard compute, there are like two different types. One is like a standard virtual warehouse you can use for data engineering workloads, and Snowpark optimized warehouse, which you can use for the machine learning workloads that are training heavy. And we have in GA today, which is Snowpark ML Modeling API. I think last week, as of the 5th of December, the modeling APIs are available in GA, which means we will now be able to use all the modeling functions in your ML workflow, even in production. And I think we've already touched upon a bit what does Snowpark look like. It's a set of client-side libraries and server-side runtimes. The client side, it has different APIs it supports. Like in the modeling, I will primarily classify them into pre-processing library and the model training library. And in the compute, of course, we talked about how having a SQL engine and a Python sandbox allows you to run both the SQL code and non-SQL code within Snowflake. Okay, so currently for the ML modeling API, we have support for these, like the most popular pre-processing functions and the most popular scikit-learn models and XGBoost models for your use. We've talked so much about data engineering and the actual ML modeling content. So what about the ML ops? What about, where to deploy the model, how to store different versions of the model, and even keep tab of all the different metadata that is associated with each of these models, which is where the model registry comes in with Snowpark Model Registry, which is currently in preview. You can store Snowflake trained models, or you can also store any of these externally trained models, like log them as part of your model registry and then deploy them and then use it. It's a simple two-step process in your existing workflow. Just log an already trained model into a registry, just deploy it to whichever compute you want, depending on what model that is, and you're good to go. Just to give you a quick understanding of how you are able to create a model registry, log a model and then deploy it all in like 5 lines of code, and that's how easy it is to get started with model registry. Easy to use, super secure, because this entire workflow is now sitting within Snowflake. Okay, so this is how the end-to-end ML workflow within Snowflake looks like. So you have the data engineering team who is using the data frame APIs on standard virtual warehouse to prepare and transform your training data. And then you pass it on, like you pass on the training data to the data science team who runs their own, ML experiments using Snowpark optimized warehouses because it's an ML workload. And they will be using ML modeling API to, build and train these ML models. And then comes the next part, which is the deployment or the ops side of it, where we have the model registry, where the data science team will log their successful models, which then the ops team will use to deploy it into an inference endpoint. And then, our customers or internal business users in the end using these, models from the registry to make predictions out of it. By having this entire workflow sit within Snowflake, we are avoiding the data silos that we talked about. And second, there is no loss of context because now, even as a data science person, you will be able to take a peek at what the data engineering workflow looks like and more. So you can understand what happens in each of these phases. There is no loss of context between the teams. And the entire data and the workflow sits within Snowflake's security and the governance boundary, meaning, like, especially for ML use cases, there is tons of data privacy regulations and governance restrictions, and you don't have to worry about any of that because the data sits in the Snowflake's security and governance boundary. All right, I think we've talked enough, so let's go ahead and write some code. And I'm going back to the same thing in case, we did not get our hands on the quick start. quickstarts.snowflake.com. You go to the machine learning one, and this is that specific quick start that we wanted to, have a look at. And the quick start had a bunch of prerequisites. Not sure if I think I'll take a quick I'll have a quick pause here for folks if you are able to get everything set, like Git, Anaconda, and Python installations. And I'll give it a minute break and then we'll get started. Okay, can you quickly let me know in the chat if you already have all of these, dependencies installed in your local? And if you are done with, installing Git and Anaconda and Python, you can also get a Snowflake free trial account. So let me go over those steps again. I think, okay. You can go to the Snowflake free trial at signup.snowflake.com. And you can just enter your details and make sure in the second screen that pops up that you want to select the enterprise. I mean, you can select anything like the standard one or the business critical one too, because we are not really going to use any of these enterprise features today. But then that's the standard one, so you can just stick to that. But then for the cloud service providers, we're going to be using AWS, so you can select AWS for that. And then you should be able to get a couple of emails. First is to activate your account. And once you activate it, you will get the details of your specific account. And I want you to, take a note of this account identifier from your emails that you will get. I see some questions. Will this work with Python 3.11? Yes, it will. But then in the code repo, like in the GitHub repo, in the Condas, I think Conda environment, that YAML, I will be using the 3.9 to create a new Conda environment. Feel free to update the 3.9 to 3.11, and then you will be able to create a new Conda environment for sure. Just make sure to update the config and you will be able to run the rest of the workshop. And I also see a bunch of questions. Are there any performance implications or costs incurred as a result of data frame translations to SQL queries in Snowflake? Not at all, actually. If you think about all the data frame operations, like the data frame APIs and the SQL, translations, they're very much like one-to-one mapped, and it's very much the same and even in the other languages, if you can think of. So there is not a loss of efficiency or optimization. In fact, the other way around, because now we're using Snowflake's proprietary SQL optimization, like SQL engine, to run our data frame APIs, it would work out even better for us. And all right. Are you all able to create the Snowflake free trial account as well? Can you just let me know in the comments so I know if you're able to? Meanwhile, while folks are waiting for the others to catch up on creating this, I have a quick poll just to understand how, like, who are we today? Like, what is each of our responsibilities and what are we doing with our work and why are we here today? So this just a quick poll on like which part of the data spectrum we fall into: data engineering, data science, ML ops, or anything else. Oh, okay. I see a lot of data science folks. So I did a good job today focusing on the ML stuff. It's almost a one-sided game against data science today. Oh, someone started the analytics game. That's cool. I think I'll give it one more minute for folks to create the Snowflake free trial account as well. And then we'll get started with the actual workflow. All right, okay. So I'm assuming that we were able to create the Snowflake trial and move forward. Okay, we will not do this now. Let's go back. Okay, once you're done with the free trial, I want us to open the terminal. And in your terminal, you can just clone this Git repository. And you might already see that in the quick start. They would have also mentioned that you need to clone this Git repository, which is where we have our code for today to walk through. And once you're done with that, you can go ahead and create a new Conda environment as well. I guess quickly going over this, we have the prerequisites, we have the Snowflake free trial, we have to set up the environment. We've not logged into the Snowflake account yet, so let's just keep that on the side. And okay, so download the Git repository and then go ahead and create the Conda environment and activate this one as well. And someone was asking if they can work with Python 3.11. Go and update this Conda YAML with Python 3.11, so it will use that version to create this new environment. And once you're done with this setup, we can go back to Snowflake. Are you able to? Okay, I'm going to the Snowflake environment part now. I was able to log into Snowflake account. And once you are able to log in, the first thing I want you to do is go to admin, billing and terms, and enable the Anaconda Python packages in here. I've already enabled, but you need to enable this one to run anything like any of those packages from Snowflake. And once you're done with that, go to worksheets, create a new SQL worksheet. And in the new SQL worksheet, you can copy this entire setup queries that we have, and you could just run them all together. I'm just going to run, I guess, just the first part. Okay, so it created everything successfully. I can go to the MLHOLDB. I have the schema, stages, assets, all of them created. And now let's go ahead and create the file format. I'm just creating the CSV file format because my input data is in the CSV format, and I want Snowflake to be able to read these CSV files from staging. So just create this file format for that. And then here is where our actual, raw data sits in. It's in an S3 bucket. So I'm going to create a new stage to load this data using the CSV format we just created. And let's see what happens. All right, so the other stage, the staging area diamond assets is created, but it's an external stage, not the internal one. And let's just list what's in the diamond assets. We'll be able to see just the CSV file from here. Awesome, so there is the CSV file, great. It's just that setting up whatever infra that we will need, and we created a new warehouse, which is the compute, and we created a database, just a logical container to store all our data, just a schema again, and created a stage to store our models, which we will train later in the workflow. And That's pretty much it. Once we're done with the setup, we could skip to the next part, which is the Python setup, which I also assume we were able to run. Can you let me know in the comments if you're able to run this entire thing? Okay. So the first thing is you can create this Conda environment. And after you're done, you can even spin up this Jupyter notebook. But after you do the Jupyter notebook part, you will have, Jupyter notebook running in your local port 8888. And you also have this setup.sql, which has exact same files, like exact same commands that we ran to set up our Snowflake account. And folks who wanted to update, you can also update the 311 here, and you will be able to install everything in here. And the next step being, you need to update your connection JSON with all the details. And in this one, excuse me, and for this one, the warehouse database schema and even the roles are pre-populated, but then you need to use your account identifier and the username and password for the free trial account here. And remember, for the account identifier, you can go to your Snowflake account, and then when you click on your, on the bottom left, you will have this account name, and you click on this account name, and it will let you copy this account identifier as well. But the interesting thing is, when you do copy this account, let's say I'm just gonna if you copy the account identifier, it's going to have this first part dot the second part, but you need to make sure that it's a hyphen, not a dot, and it will let you run through everything else smoothly. Or you can also find your account identifier from the email that you would have got. Just remember to replace the dot in between with a hyphen, otherwise it would not let you run through this. And once you're able to update your connection JSON, we are good to go. And there are like three worksheets, like three Jupyter notebooks here. The first one being the data ingestion and transformation, like the data engineering part. The second is the feature engineering. And the third is the ML model training and deployment. We will just, walk through these three different Python notebooks. And if you're familiar with Python, you will be able to run through them by yourself too. But let's just, get started with data ingestion. The first is, of course, a bunch of libraries that we have that we're importing. And as you can see here, I am importing Snowpark Python. And like within the Snowpark library, you see there are different types that are supported, and you can use the functions from there as well. And I'm also using the external library, which is NumPy, and I also have JSON to load the JSON data as well, just in case. So if I'm able to run that successfully, it runs fine. Okay, let me do this so it's easy for us to go through each of the steps. I'm able to import all the libraries needed, the Snowpark library primarily. And then the first thing is I'm opening the connection JSON that we just updated to read all the connection parameters and use that to build the Snowflake session. And once I have that, let's try to print, all the session details. As you can see, what is your username, role, and all the Snowflake objects that we have created, Snowflake version and the Python version as well, like Snowpark Python version. And we are able to connect successfully, but okay. So I see a question, where do I find the worksheet to set up the data? I don't seem to have that on my Snowpark. You will not find it does not come pre-baked. You have to go create this new SQL worksheet and then copy the code from the setup Snowflake environment and run that. All right, so let's go to our flow. If you're able to connect to the JSON, if you're able to connect to this Snowflake account, like the Snowflake instance, and then the rest of the, you know, modules run smoothly. And as you saw before, we had the diamonds.csv, which was from an external S3 bucket, and we created an external stage for that. And you could simply, like read the data from that external stage. Just like if you're familiar with Spark or even Pandas, like PySpark or Pandas, you will know this format is very similar. Instead of pd.read CSV, you're doing like session.read.csv and give all the options that you want to give. And in this case, I want to infer the schema and parse the header as well. And it's pretty much it. Let's see what the data looks like for now. Okay, so these are the different columns that I have. So it's a diamonds data set. So we have different attributes of diamonds in these columns. And in the output, which is the dependent variable, is the price. So we're going to predict the target variable, which is price here, depending on all the other input columns. And let's just, look at how many records do we have, what are the different min and max for each of these columns and more. The formatting is not the best here, but I see there are about 54,000 rows, and there are like this min and max for each of these columns. And let's just I see a lot of these null values here as well. So let's go ahead and do a bit of cleaning here. The first part of the cleaning being I would clear up the table names and just make them uppercase for Snowflake to store these values. So I'm just looking at the the column names and making them uppercase just to make it look cleaner. It's nothing to do with the data cleaning per se, but then in here, as you see, there are like different values for the cut column. How do you see that? If you go into the cut, you see it's a categorical variable with different names to it. And I'm just trying to make them all like a single variable. So later I can use the dummy, variable encoding for the feature transformations. So I'm just, clubbing them all into just one word, or like, I don't want multiple words in the cut category. So I'm just gonna, replace the space with an underscore. So how would this look like for me? Interesting. Okay, so what I'm doing is I'm taking the diamonds DF data frame that we have here, and then I pass cut column, like I pass the input column cut, and I want that column to be fixed. Like I want this column as input to the fixed values function, and then the output of that will be captured here. And as you can see, if you look at cut, we are able to replace the space, like anything other than these alphanumeric characters, with an underscore, so which has done its job well. Awesome. And this is, let's say, is the first level of, just cleaning up the data and making sure it looks okay. And let's also look at what the, data types for each of these columns look like. And like some of these are nullable, not nullable. What do they look like? And as I can see, caret is of decimal type. There are a bunch of strings and decimal types and long types, I see. And one of the caveats is currently Snowpark ML does not support the decimal type. So I'm going to convert them all into the double. And so I'm just going to convert all these columns from decimal to the double and then see what that looks like. And as you can see, I was able to convert all of them into double. Great. So let's just keep this as some sort of a clean data, which we were able to get for our training. And let's just write this data back into a new table called diamonds. But if you currently look at your Snowflake, sorry about that. So currently we don't have any tables. Our data was in the stage. If you remember, it was in the external stage, the CSV file. Okay, so that's pretty much it. We don't have any tables at all. So let's go ahead and create this table, and then let's go have a look at the table then. I don't want the stage, but if I look at, oops, sorry. Okay, so I have the table, which is the diamonds table. And let's have a look at what it looks like. It should look very similar to what we had. Okay, this color, clarity, cut, and as you see, it's all like single column, and then all the way up to all the other columns as well. And if you look at the column details, you will see there is like the double type, which is the float, and then the others are just varchars and numbers. Awesome. So we have everything and it looks good. So let's switch on to the ML stuff, which is like the feature engineering part. So now we'll move to the feature transformations. And again, very similar. We have a bunch of Snowpark imports for the functions and the data types. And here is where the modeling API comes in, and you can use the Snowflake modeling, like the Snowpark modeling API, to do the pre-processing and build an entire pipeline, and also do the correlation and other statistical metrics, like numbers that you want to run just to explore your data. So these are Snowpark ML related, and these are standard data science libraries. If you're familiar with, I'm just going to be using some of them, for our, let's say, just to plot some things and more. And of course, the rest of these import files here. So it's just imported everything that we need for this. And the connection would already been successful. We already connected it. So there's nothing new here. And so for the rest of this notebook, I want to use the specifics DB and the schema. So I'm just setting the scope in here. And once that is done, we have the diamonds table, and I'm trying to read the diamonds table into my notebook, which is our now training data. And so once you run through this, very similar to what we saw in the Snowflake UI, nothing different really. So let's get into the actual fun stuff, which is the feature transformations. So when we do a describe again, as we can see that, what is the count, mean, standard deviation, and min and max of some of these columns. And let's look at the caret column, for example. The minimum value of caret that we see in these 54,000 records is 0.2, and the max is 5. And as with anything else, if you're doing a simple linear regression, or like, let's say even here today, we will be using XGBoost as well. So let's start with how do we normalize these specific column values. And I'm using a min-max scaler to normalize. And if you are familiar with min-max scaler from scikit-learn library, you know that you can it's the min-max scaler from Snowpark is very similar to the scikit-learn one, and it's even more convenient because it abstracts away a lot of these complexities. You don't have to worry about what should the output column names be, what should the input columns names be, and like there is nothing really. You just define the input and you want a min-max scaling, and then define the output, and then you get this output column. Like it's very simple. And if you remember in scikit-learn, you'd have to create this new column and then drop the previous column. And you also have an option. Do you want to drop it? Do you not want to drop it? And there's just like tons of, I guess, boilerplate that we do. But here it's just super simple for you. And you take the input caret column and then you normalize it into caret norm. And that's it. And then you fit and transform that on your data set. And great, this looks good. So now let's go ahead and see, but you can see that the caret column has the same min and max, but then the caret norm has this 0 and 1 as the standardized variables, like the standardized values. And once we're done with that, what do we want to do here? Clearly, as you can see, the cut is a categorical variable, but I cannot use them as is. So I'm just trying to encode them into using a one hot or a ordinal encoder. And if you look at these categories that we have, there are some columns that needs to be ordinal because it means something different to have an ideal or premium cut versus a fair cut. So these values should be in an order, and the order means something. Whereas in the other columns, say for example, like in this one, like cut and clarity, although they are of different values, like different categorical values, the orders matter so much. So you do need to keep the ordinal encoder for these two columns. And then the color, not really so much. Is one color better than the other? It Are they inherently like different, these different categories? Not really. So you can leave them to a one hot encoder as well. So for, let's say, for the ordinal encoder part, I'm just going to use the cut and the clarity columns, and I define the order as well. So you define which values are, better than the other. So you rank them in the order of what is better, and then same with the clarity as well. And once you have that, you pass the input columns to the ordinal encoder and expect these output columns, and you fit and transform on your data set, and then you will have the updated data set, like the ordinal encoded data frame here. Just for us to have a peek into what does it look like, how each of these categories are indexed in these encoder. So I'm just like, when you print this using, the state pandas function, it would show you for each column name and category what is the corresponding index. So this is helpful to just see how each of these categories were mapped in index forms as well. And in the end, you can also use the one hot encoder to transform these categorical columns into numerical columns. For example, color did not really have any ordinal function, so you could just use a color as a one hot encoding. Like you can pass color into a one hot encoder and do that. But in this case, I've just used this one hot encoder just to show you, but I will not be using that in the actual ML model at all. Because if I remember correctly, cut and clarity are ordinal values. So I've put them in ordinal encoders, not into categorical. This is just to show you that you can use one hot encoder as well. And in the end, so let's put them all together and build a pipeline. So these are my categorical columns. And what are the outputs of these ordinal encoders are these. And what are the numerical columns? I have these numerical columns. And for all the categorical columns, I also need these orders mentioned. So I'm mentioning them in whatever order that I deem, correct for the specific column. And here is the pipeline function. It's very similar to sklearn, like scikit-learn pipeline. Again, you can define your entire pre-processing and standardizing and normalizing and actual training pipeline. So here we only have two pre-processing functions. One is the ordinal encoder and the other is the min-max scaler for the caret column. So once you do that, you can define your pipeline file as a job-lib and then add it to the stage as well. So let's just, if you run this, pre-processing pipeline and fit it on our diamonds data frame, you will see that, all the scaled up and standardized values are here. And it's kind of hard to make sense of some of these data because now it's all like numerically encoded. But let's go ahead and, save the pre-processing pipeline file into our stage as well. But once I have to run through the entire steps to do that. Okay. We were able to build the pipeline. Okay. So now let's go ahead and check in our stages. Do we see a pre-processing? Tables, stages. Oops. So what is the name? MLHOL assets. Oh, okay. So we already have this MLHOL assets, but we don't see it. Let's. Interesting. Maybe it takes a few seconds. Let's get back to it in a bit. And then, so once we have all the data processing done, what does like data pre-processing done, what does the actual data set look like? So this is how it looks. Everything is like we were able to write that the pre-processing job lib pipeline into the stage, and now we will read this the pre-processed data frame, like the transform data frame, and try to do a simple correlation and see what it looks like, right? And it's a bit hard to look at the numbers and make sense, but then I could still see that some of these columns, like caret is highly correlated with this XYZ columns. Oh, and even the price, of course, the higher the caret, the higher the price. I guess it makes sense. Just trying to, put a visual representation on top of this. So I'm just creating a mask to add it onto this, correlation DF and then plot them as well. This way it becomes a little easy and clear to see. Price is highly correlated with caret and the XYZ variables, very similar here as well. And let's just, of course, when it makes sense to have the price and the caret highly correlated. And one of the things is that we are currently trying to convert our, the Snowpark data frame into pandas and then use that for the actual, matplotlib and the other functions, because currently you cannot, like the Snowpark does not really support the matplotlib and the other libraries to plot it. So I'm just converting them into pandas and then passing the pandas data frame to plot this, scatter plot. And I can see that, how as the caret varies, the price also varies, but it's not linear, almost like an exponential or like 2x function. And just like exploring what the different columns in the data looks like. But primarily we were able to transform the data by just encoding a few columns and then scaling a caret column. Just also now overlook what the different features look like and make sense. And once that is done, we also were able to write the pre-processing pipeline back to Snowflake. So now let's get into the actual modeling part. And before that, let me just clear the output. It's easy for us to follow through. Very similar again, we have the modeling API. We're using the XGBoost and the model selection to have, grid search survey for the hyperparameter search. We're also going to use the model registry to store the models now. And again, from the modeling API, I'm also using MAPE as a metric to optimize for. And a very simple import, we were able to get through. Then connection, we were already able to get all cool. I'm setting the scope again to the specific database and the schema as well. Life's good. And okay, so now this is the actual training raw data. And then we did this, some of these are categorical columns, some of these are numerical columns. So what is the label output, right? So this is the label column, and what is the expected output, which is the predicted price. Now we're going to calculate the predicted price and compare it with the price, and then use the MAPE error to see how good the model predicted it. And what is the pre-processing, file that we're going to use, the one that we already have stored. And it's just like I guess the classic boilerplate that we've already, figured out. And now for this one, I'm going to be using an XGBoost regression model. And let's see if we're able to split the entire data set into training and test set with just 10% to the test set for me. And once that is done, I'm going to create an XGB regressor with whatever input columns. All of the categorical and numerical columns are input columns. And the output is going to be the predicted price, and the labels that we have is the actual price. And let's just fit and predict on the data set. And once we have that, it runs for a few seconds, and we'll see what it looks like. I think while that is running, let me just look at this. Oh, okay. So I see in the chat that some of you are not able to connect to Snowflake through the notebook. Like, what errors are you running into? Were you able to update the connection.json? Mm-hmm. All right. So we were able to, you know, fit and predict on the model. And the next step is this is again just to show it's not necessarily a next step, but you can, if you had suppose trained your model on pandas, like using pandas data frames, you can pass pandas as an input to the existing Snowpark model as well. So just to show you, like I can convert an existing Snowpark frame into a pandas data frame, and I can still pass it to the existing predict function. Okay. And for the error that you see, are you updating the connection JSON with the right account identifier and the password and the account details? All right, like I showed again, even if you use pandas, if you have your data in the pandas format, you could still pass it on to the Snowpark trained model as well. And let's just calculate the error. We have, the result set from the prediction. So I'm going to use that result along with the price, and to the result set will be the predicted price, right? So I'm going to use that to create, like, calculate the map error. And what does that look like? Okay, it seems not so, I mean, very close for some values and not so close for a lot of values. And like the value, I guess the map value itself absolutely is 0.07. And what does it even mean? So can we just look at the actual versus predicted values so we have an understanding of what it looks like? Okay, almost there really. I guess this feels like a good model, like for the first iteration. It's I do see a few points up and below that's kind of way off the line, but it's pretty much a good deal otherwise. So now this is again the first iteration of the model. Just as any other data science person, let's go ahead and run the, hyperparameter tuning part, where let's try to give, a couple of possible values that we want to iterate with for the number of estimators and the learning rate. And then we want to optimize the mean error, and let's see how that comes to be, and if you're able to come up with what the ideal values for the estimator and the learning rate are. And it takes a bit of time. All right, I think while that is running, I have a quick question. Uh, Or okay, I just put a poll out there. Are you familiar with Snowflake's like Snowpark ML and the AI capabilities before this one, or is just this? All right, this is. I see that some of us think no. That is super interesting to learn. So this one does take a few seconds. Maybe I could have cut down on the number of values, like possible number of values for the hyperparameters. But then let that run while it is trying to identify, the optimal model from the given set of hyperparameters. Let's, like go ahead and see what the further steps look like. And well, currently, because we still don't know what's the final model is going to be, but then in the past, when I had ran this, oh, okay, so we were able to run this successfully. This is great. The grid search CV ran, and as you can see, what does this best estimator look like? There are no boosters, nothing. We were only playing around with the learning rate, which seems to be zero point 0.4. So zero point 0.4 is the optimal. And what are the number of estimators, which is 500. Okay, this is what the the best model parameters are, and I'm going to use that to just plot my values again for each of these number of estimators. And for the learning rate, what does the MAPE error look like? And if you look at the graph, of course, for the learning rate of zero point 0.4 and with the number of estimators 500 is where we get the least MAPE error. So I guess it makes sense. It's consistent with what we saw before. And so I'm going to use that model, like the best estimator model, to you know to see what the MAPE error is actually for that. Like we use this price, and let's just see what it's going to be. All right, so from 0.07 we were able to go to 0.06. It's just like a very small difference, but you can see in terms of values as well, it's all a bit closer to the actual price, the predicted prices are. And let's just do another quick plot to see how they look in terms of, I guess it's very similar, not like, I guess at least to the human eye, it's hard to differentiate, but maybe there are a lot of points that are above, like which are far from the line. And you can see here, maybe it's a little less values over there. And here comes the fun part, deploying the ML model, like actually like building the model, pre-processing it, creating features, and hyperparameter tuning in is all like most of the data science work. But how do you actually deploy it and store different versions of the model along with its metadata for inference is the ML ops stuff. So we have model registry to help us here. So you can use that optimal model, like we can say the optimal model is the best estimator we got from the grid search. And then we're going to use the estimators and learning rate we got from there as well. And we will create a new DF from the optimal learning rate and the parameters that we got. And let's see, what does that look like? And once we have that, we can there it's a two-step process to use a model registry. The first is to log the model, and the second is to actually deploy the model. And to log the model, first I'm going to use the training data and then get the DB in the schema and define a model name, whatever version for the model that I want to keep and everything. And then I need to initialize the registry because currently we don't have any registry. So let's go ahead and initialize the registry with this database and this schema. And so I have the model details, which are defined here, and I have the registry here. So let's go ahead and log the model in that specific registry. And I also want certain metrics to be captured, which in our case is mean absolute percentage error, MAPE. Yes, the model registry is in private preview, so it's just for us to understand how it works today. Awesome. So we can just list the models and see what it looks like. And currently, the model registry probably will have just nothing because we only like deployed it. Oh, we logged this model as well. So you can see that new model with the metrics, registration timestamp, and everything, even the environment specifications which you used and more. And once you have that, so currently we only have logged the model and it is not ready for inference by your consumers yet. So we'll have to go ahead and deploy a specific model. And for deployment, you can always mention what is the name of the model, version, what do you want to call the deployment, and more. And once you deploy that as well, whatever the deployment name you're using here, you just need to, like, say for example QA and prod and staging and whatnot would be the deployment name, and the model name that you use you could just, oh okay, so it's taking a while to deploy. It's just a few seconds, so let's give it that time. All right, so once it's deployed, you're now able to see what was the name and where was it deployed. It's in a standard warehouse. The target method is predict, and what are the different features it takes, what is the output feature it produces, and like where the model is actually stored in a staging location, and all the details about the model is now available. Now, we deployed the model. Now, how do we actually use it at the inference time to call the model, for example? And as you see here, you create a model reference from this registry, this model, this specific version. You create that model reference and call it model ref, and you use this in the inference time and just call the predict method with your input data set. And this is just to list the models and see if it is there. Of course, it is there. And the deployment name is here updated as well. And at the inference time, you just use that model reference and then run predict on that. And in the end, you can do the cleanup and delete the deployment, delete the models and more, but it's not mandatory for us to clean it here at least. But you can clean it in your own actual deployments if it's not needed anymore. And I've also added a bunch of appendix stuff to you to go through if you are working with, if you're a SQL person working with UDFs and store procedures and you want to use the vectorized UDFs to deploy your models, you can do that as well for batch prediction instead of doing, one row at a time, for example. And I think this is pretty much it for the workshop. If you're able to run through these different Jupyter notebooks, that that brings us to the end of it, and you have this end-to-end flow. And I also wanted to like quickly run through like what next, for example. Like whatever we talked so far is like classical traditional machine learning functions with scikit-learn and XGBoost and like whatnot. Then there is also these tons of new LLM features that are available to you. And if you want to start working with LLMs and Snowflake as well, you can check out the other relevant quick starts that I have here for you. And I guess that's pretty much it. Thank you so much. And I will leave this quick start page for a few seconds for folks who want to get started with advanced ML modeling, because today what we did was almost like an end-to-end ML workflow, but more like a 101 class, not an advanced complex ML workflow. But if you do want to get started with advanced workflows or LLMs, refer to this other quick start that we have. And with this, we are at the end of it, and I will get through any of these questions at the minute. Okay, so I see some of the questions with the problem connecting to Yeah, okay. Ah, okay. Some of us have problems connecting to Snowflake. I guess, like, if there is any connection problem, check your account identifier, which I see is the most common issues for the connection JSON. And for the other person, error detecting the version of lib crypto. Is it because, ah, okay, so I see you're able to like progress from one error to other and keep going and let me know if you have any other questions. I guess I'll give it about a couple more minutes. If you have any questions or need link to any other resources, I'd be happy to help. And otherwise, thanks so much for joining. And it was great presenting and learning more about ML with Snowflake.
Thank you so much, Vino. That was a fantastic workshop.
Mhm. Thank you. Can you show again where to get the ID from? You can get the account identifier from your Snowflake account on the bottom left. If you click on the ID, it would ask you to copy the identifier, and you should replace the dot with a hyphen in the account identifier, and it will help you with that. Maybe I should share the link to my slides too.